Hi, I'm Dan, and in this video I'm going to talk to you about some speed issues in Unreal and some ways to make a very quick start on dealing with some of these things. You'd think with a program as complex as Unreal and with the size of projects that beginners in Unreal play around with, that you wouldn't come across any speed issues. That's not true. You don't have to be going very far before speed and frame rate can start to hit you. But there are some very simple things that you can do about that. So the first thing I'm going to do is I'm going to show you how to look at a speed profile um, for the frames that are being drawn. And you can't see my hands, but I'm doing Control Shift and comma. So Control Shift comma brings up the GPU visualizer, and here that gives a snapshot of the frame, uh, or of a frame being processed. And you can click on the side button on there to get a breakdown of the different aspects that are going on. So what I'm going to spend a little bit of time looking at is the lights. So here, this is the calculations for the lighting for the scene, and it's 0.15 milliseconds, which is pretty decent here. So I've mentioned lights because this is the first thing that we can deal with, is that very often speed issues in starter things are to do with lights. And when you start getting a nice shiny environment with lots of different lights in it, then that can slow things down considerably. But there is something very basic that you can do about that. So what I'm gonna do is I'm gonna throw a few lights in here. I'm just going to put a few point lights in there. Whoa. Let's have 6 of these at various points. 1, 2, 3, 4, 5, 6. I'm also going to stick a couple of spotlights in. Just there. There. And just for the sake of it, I'm going to change the colour of the spotlights. I'm going to have a green light over there. And this bit over here is going to be my red light district. So, red like that. Okay. So the first thing that happens when you make any changes to the lights is that you get this message that lighting needs to be rebuilt. And that's because it hasn't done all the calculations that we need to do with these new lights and scenes. I'm wondering why that's got a cross in it. Never mind. Right, build. So to build the lighting, you go build, and you can do build lighting only. And this brings up a curious process that seems to take longer than it would need to. Because it talks about building the lighting, and then it starts talking about, yes, the light build's complete, and we've got some messages there. Unreal's really clever in the way it deals with lighting and building lighting, because obviously this is a really simple situation that I've got here, but often it can get really complicated. And what it does is it uses a kind of swarm system, which allows light building to be done by more than one computer. And in fact, I think it calls out to other computers over the internet that are currently running Unreal to help with the processing. So the lighting's built. So a quick jump in here. We've got various places where these spotlights are taking effect. We can see some shadowing going on there. It's nice. We've got, this is our green light here and our red light over here. Okay. So let's have a look at that speed. So Control Shift comma and have a look at our frame. I'm looking at our lights now. The lights bit here has considerably increased. You'll see it's 0.70 milliseconds, which is really quick, but we've only got a few lights in. If we started to make a mansion or some kind of temple and we had lots of subtle lighting going on, then this builds up really quickly. And this is one of your biggest causes of slowdown in Unreal is lights. Now, what happens with Unreal is that it actually puts when you put a light in the scene, there are 3 mobility settings down here that you can have, and they're put as stationary as a default. So the difference between them is movable means you can have this light so that it moves. It might be attached to something. It might be on a chain and can swing side to side. So the actual light source can itself move. So if you want a light source that does that, you're going to need movable lights. Stationary lights are lights where they don't move, but you can change the parameters of them. So you can change the color, you can change the intensity, and other parameters. And a static light is a light where it can't be changed once it's in game. So when I say stationary means that these things can be changed. I mean dynamically in the game they can change whilst the game's running. A static light can't be changed in the game, so the lighting is fully baked beforehand. Um, and for speed, if we don't want anything clever with our lights, the simplest thing we can do is just to switch all our lights to static. So like static. Let's see if the crosses are going away for some of these. Sports. Static. Spotlights. Right. So once again, it says the lighting needs to be rebuilt, so we'll do that. All lighting only. It's starting with the swarm connection. Build lighting process. This is not too good. There we go. And we'll do our shift control comma and have a look at what our light's doing now. So extend this down and we can have a look. Here's our lights. It's much smaller. In fact, we're down to 0.20 of a milliseconds. So it's made a significant difference to that. And in fact, we can go even further with this because there are a couple of built-in lights in this third-person template, which is the skylight. If we're not going to make any changes to that, and usually we're not, and a directional light source. Yeah, and we're going to turn those both to static. Once again, we're going to build our lighting. Build lighting only. It's kind of previews grayed a little bit, but this should go back to normal once we build the lights. There we go. It looks slightly different, but this is the way it is. We'll do our Control Shift comma again to get up the frame. Have a look at the lights. Now the lights are tiny, in fact. Highlight it. If I can even use to highlight it. See that the lighting calculation is 0 because all the lighting stuff has been pre-calculated. And so that's made a significant difference. We've still got our point lights. So the thing that we lose from this is that we now see that our point lights aren't casting shadows anymore because all the shadows are pre-baked. So actually, let's be clear on that. They're not casting shadows on my character, but they have cast shadows on the static things that are in the scene because it's pre-calculated those. And in fact, what's happened is that this thing that looks like a shadow down here is actually part of the texturing here. It's been texturing on the film because that's what's called pre-baked lighting. Okay. There are a few other things that can influence speed in Unreal. Let's stick to the lighting and let's just introduce a particle effect because the particle effects can be quite expensive. Particles, and we're just going to put a fire. Let's put a fire down here because there is one more thing that I want to show you with the lighting before we move on, which is that. So we've got our fire here. It looks nice. Now, whilst we're playing, we press F5. F5. What we get is a viewpoint which overlays the shader complexity. So this is to do with the graphics rendering. And you see most of this is green, which means that the graphic shaders that are being used to draw these pixels where it's green are very good. It's very, very quick. But once we've introduced the particle effect, there's a lot more stuff going on just down here, and this is edging into bad. And so this is a way of looking at scenes that you've got and looking at where the complexity is of your shader rendering. So that's another way that you can find out and highlight points of interest, places where you might be able to reduce the frame rate if you're having a problem with it. Let's click back out of that. So yes, there are just a couple of other things I wanted to talk about in terms of speed. So the first one is geometry objects. So I don't know if you've come across and been using geometry objects. These are things that you can use for quick prototyping of scenes that you've got. There hopefully will be another video, I haven't made it yet, that will highlight this sort of stuff, and you can use this for blocking up the walls. In fact, there is going to be a video on how to block out a level using these geometry objects. And they're a really good and quick way of dealing with space. However, you'll find once you start getting complex levels, if you've blocked it out all with geometry objects, they cause a slowdown. They are much slower to render because they're done in a procedural way. That doesn't mean like roguelikes. It means that the information that's being used here is very basic and simple information, and it extrapolates from those parameters to try and tell you, not to try, to actually determine where things are drawn. So there's a lot more calculation that needs to go on when you have a geometry object than does when you have a static mesh or even a skeletal mesh. So one of the big things you can do in terms of speed up is to take your geometry objects and to turn them into static meshes. So maybe we've done this, maybe we've had a stick of material on it. So I'll just quickly check materials on that. There's it on particular surfaces. And then inside this box brush, in the brush settings, go down here, click Create Static Mesh. It asks you where you want to put it, and then it's created that as a static mesh. If you do that to all your geometries, once you've got the shapes how you want them, then that can give you a huge speed up in terms of your level. So I've commonly seen this where I've had people doing a lot of geometry objects. The third and final thing, I've not got a demonstration for this, but that I want to tell you that the speed of rendering depends on how much you can see. And so this is why you might have noticed in some games when you have certain things like a city, you might not get really long straight streets. And this is about cutting off the line of sight. And your rendering goes faster if your line of sight is shorter. Now, there are some games where they do all sorts of tricks using level of detail to make this better. And Zelda Call of the Wild has got this really good feel of open spaces. But if you're having trouble with speed, think about if you've got a line of sight issue, and if you're allowing the player to see further and see more than they really need to, because that can cause quite a slowdown on your graphics. So that's a quick overview of some of the things that you can do to avoid starting speed issues. The two big ones are changing your lights to static and turning your geometry objects into static meshes. So I guess the key here is to use the word static for everything that you can. And then there's a hint there about line of sight as well. Anyway, that's it from me for now.